Hi guys, day 5 of the probability unit. We are talking about independent versus dependent events. All right, so think about like at age 16, you want to be independent, you want to be able to do stuff on your own, right? Whereas dependent, maybe you can't go anywhere depending on whether or not you get the car. You get the deal. All right, so what does it mean in probability land? It says, easy example, a hat has 9 cubes. 4 are red, 5 are blue. When 3 cubes are selected randomly, what's the probability that all 3 are red if we select each cube with replacement versus without replacement? All right, so replacement just literally means, all right, I'm going to pick the cube out, but then I'm going to put it back in the pile so it could get picked out again, right? So in that case, what I want you to keep in mind is what is just the probability of picking, a red cube in the first place? So there's 4 of them out of 9 total. That part's super easy, all right? So when you pick with replacement, the first time you'd be able to pick it, it'd be a 4/9 chance. Since you put it back in, it's still 4/9 the next time. It would be still 4/9 the third time. Whereas when we're talking about without replacement, right? So I take the cube out and now it's no longer in there. So the first time there's a 4/9 chance, but the second time I go to pick, there's only 3 red cubes left and there's only 8 cubes total. So it'd be 3 out of 8. And then the third time, there'd be 2 red cubes left, and there's only 7 to choose from, right? So the numbers change. This is called independent events over here, right? This one would be dependent because it depends on what happens the first time, and the numbers change the second time around. So when it says which one seems to have events that are independent of one another, well, that's that guy right there, all right? The with replacement. And then what does independence mean to you? All right, well, we talked about it, Goofy being out in a car or something, but in this case, what independence should mean is that one event does not affect the probability of the next, all right? So we say independent events are if oh my goodness, if 2 events are independent and event A occurs first, it will not affect the probability of event B. Oops, I'm so sorry, I'm off the screen there. Right? So independent, right? The chance that you slept in this morning doesn't really affect me being able to get up and do my work, right? Those would be independent events. Whereas the probability of having the prom being dependent on school being open, yeah, that changes things, which, sorry about that, guys. That bums me out for you. It was supposed to be my niece's prom too, I think last weekend, and it's just sad. All right, moving on. So with that being said, it says determine whether the following scenarios show pairs of events that are independent or not. So you got to think, would doing the first event affect the second one? So we're going to put an I for everything that's independent, a D for everything that's dependent. Or you could put not I don't care. All right, so tossing a coin 2 times and getting a tail on both tosses. Unless you have some trick coin, that should be completely independent. The first toss shouldn't affect how the second toss goes. Right? Wearing a raincoat and it raining today. Now, I'm not saying if you wear a raincoat, it'll cause it to rain, but would this depend on maybe that? Yes, absolutely. I probably wouldn't put my raincoat on if it's not raining. So I would say those are dependent events. Raining today and your chemistry test grade. Probably not. Those are probably independent. You could blame it on the rain if you want to try, but coming to school and your bus breaking down. Well, right now we're all at home, so this one's kind of, a moot point, but typically if your bus breaks down, that might stop you from being able to come to school. So I would say typically those are dependent. Sometimes people argue that one. It doesn't matter. All right. I just want you thinking about it. Don't worry if you don't 100% agree with all of my answers. Right? Drawing a 10 from a deck of cards and drawing an ace without replacement. As soon as you see the words without replacement, that means we're going to be dependent. All right. So it's the fact that there'd be one less card to pick from. The probability of choosing the ace is going to change a little bit. All right. Let's see. Drawing a 4 from a deck of cards and drawing a spade, but with replacement. As long as you put it back, you're good to go. No one will ever know. It won't change the outcome. All right. Rolling 2 dice and getting a 3 on 1 and a sum of 11. All right. If it had said a 3 on 1 and like a 2 on the other, like the next one, those are completely independent. But let's say you get a 3 on 1. What's the most you can get on any die? Well, 6. So 3 plus 6 is 9. So if you get a 3 on 1, yeah, you're not going to be able to even get this sum of 11 on the other one. Those would be totally dependent events because it depends on what you get on the 2 as to whether or not you can get that sum. That one's a little tricky. Last one. A person flips a coin, notes that it comes up heads. The person rolls a 6-sided die, notes it comes up a number less than 3. Those have nothing to do with each other. One is not going to affect the other. Those are independent, right? So you just have to start thinking, like, does one change the other? Does it not? As for back up top, we talked about those independently, but we never ended up kind of putting them together, but we will, all right? We will put all that together, all right? So hold on for that. The test for whether or not something is independent. Ooh, let me slide that baby back up. Here we go. All right. I'm going to say if 2 events are independent, then the probability of A given B is the same as just whatever the probability of A is, because B didn't have any effect on A. All right. Or we can do it the other way around. The probability of B given A is the same as just plain old the probability of B, meaning that A had no effect. Right? So I'm going to say B has no effect. And I apologize for my spellings of effect. This is where I need you guys here with me, because I always misspell like which one for which case. And every year my smart students always tell me, Mrs. Merritt, it's this way. But I don't know. All right. I'm not saying it's unimportant. Your English teachers would cringe. It's very important. I'm just saying that it's not my focus at this moment. So my apologies. You spell it the correct way. Okay. So the idea, if they are independent, meaning B has a no effect on A, then the probability of A, given that B happened, should just be the same as the probability of A by itself. Like those numbers aren't going to change any. All right. So something to note, if they come out unequal, all right, then the 2 events are not independent, or you can say are dependent. So somehow, like if they come out different, somehow that second event changed things for event A. Mm-hmm. Okay, let's slide it on up. Ooh, I apologize, we're a little crooked. There we go. Okay, this first one says a survey of 56 sixth graders was done to determine which subject was their favorite. Now, even though all the votes should be in the math column, we had to throw things around and make it look realistic. The results are shown, sorted by male and female, and then there are options here, math, English, social studies, science. When I ask my second grader, he just says recess, but whatever. All right, what is the probability that math is their favorite subject? Well, look at the total for the math column. That's the 18 right here, out of how many total kids? 57. So 18 out of 57. All right, what's the probability that you pick somebody and they happen to be male? Well, there's 27 males out of 57. Right? What's the probability that they like math and they're a male? So go to the overlap. Math and male, there's those 10 kids right there out of 57 total. Easy. All right, now here comes the conditional probability, which we did the other day. What's the probability that you like math given that you're a male? Remember that that word means given. So in this case, the easiest way to do this would simply be to look at the male subset. So I'm going to come up here. I'm going to use my handy dandy yellow marker here and highlight the male subset. So if those are all the males, there's 27 of them. How many like math? 10. So it's 10 out of 27. So you could have done what's the probability of both divided by the probability that they're male, but look at what would have happened. You would have had 10 out of 57 over 27 out of 57, and that would be 10 over 27 right there. So I can put that off to the side. That's the both divided by the probability that they're male, but ta-da, that's going to give me the same darn thing just by looking at the overlap out of the total number of guys. All right, now let's do it in reverse. So let me grab a different colored marker here, or I got a red pen at least. All right, what's the probability that they're male given that they like math? All right, let's look at all the math people. Woohoo, math people. All right, there are 18 total math people. And how many of them are male? Well, 10. So 10 out of 18, which would have been the same as if we had done the both, 10 out of 57, and then divided it by the probability that you are male, which would have been 18 out of, or excuse me, that you love math. That was 18 out of 57, and there's that same answer, okay? But you reading the charts, it's actually super easy if you just think about, all right, the second part being my subset. So you're looking at this little subset, and then how many of them are male, given that they're in the math category there, right? Then it says, does it appear that the events of preferring math and being male are independent? All right, so preferring math and being male, this is where the test from above comes in. So you can use it in either order. It doesn't actually matter. So let's use it the way we did for part D. The probability that you like math, given that you're male, we would have to test and see, is that the same as the probability of just the first part, liking math all by itself, all right? So this is like the A given B, is that the same as just plain old A? So this first part we already calculated. This was 10 out of 27. Probability that you like math was 18 out of 57. So I'm just stealing that answer from up here. And then to really be able to compare them, turn them into decimals. So 10 out of 27 is about 0.37. And then 18 out of 57, 0.315. So they're close, but they're not exactly the same, right? So those are not equal to each other. So when it says, does it appear that they're independent? Then I would say, no, they are not independent, right? The fact that this one is about 0.37 versus this one's about 0.32, as your female math teacher, it pains me to say this, but it appears that you're more likely to like math on this survey, given that you're a male, all right? So the guys here like in math a little bit more than the general population. All right, fine. All right, last one. The probability that a person is left-handed is 12%. Probability they have brown eyes is 42%. Probability they have brown eyes and are left-handed is 2%. Is the event of having brown eyes independent of being left-handed? Support your answer. All right, I am always so intrigued by left-handed people. I don't know why. I tend to wander around the classroom like checking out if you guys are right-handed or left-handed. So the probability that you're a lefty is 12%. So I'm going to make that 0.12. The probability that you have brown eyes is 0.42. And the probability they have brown eyes and are lefties. Okay, so both. So I'm going to say brown and left. I'm just abbreviating there. 0.02. Okay, there's our information. So it says, does it seem like those two events are independent? All right, so how we would have to look at this is the probability of one given the other, is that the same as the probability of the first one? So I don't really care which way you do it, right? So let's say as an example, the probability that you're left-handed given that you have brown eyes. So like I have brown eyes, but I'm right-handed, all right? So are you more likely to be left-handed given that you have brown eyes than just, being left-handed alone, or maybe less likely. So we're checking to see, are these equal to each other? All right, how to calculate the given one? That is the same as the probability of both, so L and B, divided by the probability of the second part, because you got to be in the brown-haired category in the first place, and then be a lefty and brown hair. All right, let's do some quick calculations. That is 0.02 out of 0.42. We're asking, is that the same as the probability that you're just a lefty in the first place, which is 0.12? All right, let's calculate 0.02 divided by 0.42. They're saying if you have brown hair, the chance that you're a lefty is just shy of like 5%, so about 0.05, which is not the same as 0.12. They're actually saying it's a lot less likely that you'd be left-handed given that you have brown hair. So when it's saying, is the event of having brown eyes independent? No, they're definitely dependent on one another, all right? So something to do with your DNA kind of makes sense. So maybe, I don't know, maybe redheads are more likely to be left-handed, or maybe blondes. I'm not totally certain. Who knows? But they're just saying, yep, that they do have some sort of relationship to one another. All right, last page. Let's jump back. We got a little spinner question, and then we're done. So last page, it says you got an 8-sector spinner. Woohoo, it's back. Once the spinner is spun once, the outcome is noted. Answer the following question. That seems very not like a normal sentence. So was mine. All right, back it up here. Let the event S be the event of getting a perfect square. Ooh, so perfect squares. Oh, you shouldn't have to know what they are. You guys should know what they are. What's the probability of getting a perfect square? All right, so if S itself is 1 and 4, the probability of spinning a perfect square, well, there's 2 of them out of 8 total, so 1/4. Easy, done. Let E be the event of getting an even. All right, so think about your even numbers. Notice they didn't tell you, because dear Lord, you should know what those are. All right, so what's the probability of getting a perfect square given that it's even? So the probability of a perfect square given that it's given that it's even. That means you have to be in the even set first. So this is your little subset here. All right. Well, there's 4 even numbers. What's the probability of your perfect square? Well, only one of them in that set is a perfect square. So it would be a 1 out of 4 chance. Right? Are the 2 events independent or dependent? All right. Well, the probability of getting a perfect square on the whole board was 1/4. The probability of getting a perfect square given that you're even is 1/4. So the fact that the probability of S given E is the same as the probability of S, right? They're both 1/4 equals 1/4, means that they are actually independent events. Which really just means you're not more likely, to spin a perfect square if you have the evens or if you have the odds on there, okay? The last part, let M be the event of getting a multiple of 4. Okay, so multiples of 4 on here would be 4 and 8, so that's the set we're talking about. What is the probability of getting a perfect square given that you got a multiple of 4? So the probability of a perfect square given that you spun a multiple of 4. Well, given that you're in that category, there's only 2 numbers there. Right? One of them's a perfect square, so it's a 1 out of 2 chance. Are the 2 events independent or dependent? All right. Well, is the probability of spinning a perfect square, given that it's a multiple of 4, the same as the probability of just spinning a perfect square? Well, this is 1/2. We said that that was 1/4. No, so they are not independent or they are dependent. Right. There we go. It says explain. Well, hopefully that's kind of our explanation here. You can say you're more likely to spin a perfect square if the number is a multiple of 4. So, oops, so sorry. I wrote it and I'm off the page. All right. Hope that helps. The notes should be identical on the website, minus maybe some verbiage, but otherwise they should be good to go. So you've got this tonight, you've got one more day tomorrow, but you don't owe me any homework until next week. All right, guys, have an awesome day.